Hello, and welcome to 3D Printing News Unpeeled, live with yours Peels, courtesy of 3dprint.com. We have 5 news items for you today, and the number 5 one is the combination of 3D printing and masonry. And this is a project by Su Ching Fu, and who's a stone craftsman who uses traditional methods and traditional materials, and Li Yan Yu, a digital fabrication researcher from National Yangming Chiao Tung University. So what they've done is something that I call combinatory manufacturing, and they've combined old materials which have a beautiful feel and elegance to them, are wonderful to the touch, and they have a certain luxury to them as well, and old skills, and they've combined it with additive manufacturing technologies to create a new object that's a combination of the best of both worlds, if you will. So they're using materials like dark jade, white marble, fossils, and just powder bed fusion to create these cutlery objects in this case. Um, I'm not sure if 3D printed cutlery is going to be the be all end all for everyone in the future, but I do know that this kind of approach is a really elegant one at solving some problems. Like, for example, the touch and feel of things, or the cost structure of 3D printing, or the fact that certain, that sometimes our products aren't seen as being luxurious enough. In other cases, our products aren't functional enough, and other traditional methods are much cheaper or more functional or better looking. So the idea of taking the best of both worlds, I think, is something that we need to see more often. And I think this is a wonderful example that we saw in Design Boom here. The next is a bridge. You may have seen this before. It's a Swiss-Austrian team that made a 3D printed concrete bridge for the Venice Architecture Biennale. It has won the first AJ 100 Innovation of the Year award by the Architects Journal. So that is good news, obviously. But it's good for us to look at what the collective architects on the jury thought of this and why they liked it so much. So they liked the lightweight design. They liked that it avoided waste. And they liked that for the Biennale, it was actually installed and then taken away. And it was designed in such a way with fasteners and blocks, 53 blocks total. So not one structure, but these 53 structures that make the bridge easy to be replaced, and also could, in fact, make it easy to replace certain fasteners and also certain individual blocks to repair it in part. Um, if for example, like maybe the entire bridge isn't very load bearing, but then you replace certain blocks which have been under load for a long time. Usually in 3D printing, we try to make a structure in one go. So maybe this block type approach is something for us to think about as well. It also lets you transport things much more easily to the location. For example, the bridge itself is an arch, 16 by 12 meters. And it's got 4 distinct entrances. It's made by the Block Research Group, the ETH Zurich, Zaha Hadid Architects Computational and Design Group, and it was 3D printed by Incremental3D. And the materials are provided by Holcim. So this kind of partnership took 84 hours to print the bridge. And the reason that I'm less, the world is very interested in 3D printed houses. I'm less interested in that, but I'm very interested in 3D printed formwork because it clearly saves money in certain instances. And also I'm very interested in 3D printed bridges, especially foot bridges and short span bicycle kind of car bridges, things like that. Now, the reason for that is in the 50s and 60s, we had a giant boom in construction in Europe because of the Marshall Plan and the later economic growth. Similar things happened in China, or in Japan and South Korea, United States also, and a lot of other places in the world, albeit less dramatically. So we saw a very accelerated time of construction of all sorts of things using concrete and steel over concrete over steel kind of building methods. Um, these things are starting to deteriorate. A lot of the, for example, apartment buildings that were put up very quickly, or the houses that were put up very inexpensively after the Second World War, have been replaced gradually, bit by bit. But a lot of these infrastructure items have not, which means there are thousands of bridges worldwide that need to be replaced in a very short time span. And we have an aging working population, especially one of the most aging working populations is construction workers in a lot of countries. So there is a kind of bit of a crunch time coming for especially these kind of bridges. And I'd like to think that a lot of the building decisions are decided either by cities and committees in these cities, or are decided on like the relatively local level or state level, depending on what country you're in. I'd like to think these people could be really open to something that saves weight, that saves CO2, that is award winning, that is something that will give a little bit of a excitement value to their park or their bridge or their tunnel or their neighborhood. So I think this could commercially have very, very exciting prospects, this kind of thing. So that's why always watching the 3D printed bridges, the MX3D bridge, and all the other bridges uh, that other companies are doing worldwide. I'm very excited by this. The next one is also very, very exciting. That's Hermeus is using Velo3D. If you haven't heard of Hermeus, you should have. It's a startup that's raised over 130 million. And normally I would say that's a lot of money, but for what they want to do, it's not a lot of money. They have a lot of support from the US government, and they have a real true rock star team of some incredibly gifted and really experienced aerospace-based people. And it's good to have all these things because what they want to do is very, very ambitious indeed. They want to make hypersonic aircraft. They want their first plane to fly in 2023. And hypersonic, again, is airplanes or airplanes or glide vehicles or that can attain controlled flight at speeds of over Mach 5. So controlled flight over Mach 5 and also be reusable because like there's some countries that make claims to having hypersonic vehicles, but actually what they're doing is it's just a rocket will go that speed before it impacts essentially. So the idea is to get a hypersonic aircraft that is repeatedly, one time after the other, capable of achieving speeds of Mach 5 and over in a controlled way. And this, of course, is a huge challenge. It will be very, very expensive for them. And it's good then for the Velo3D that Hermeus just announced that it has a Sapphire and a Sapphire XC is using components to build their Hermeus Chimera engine and the Quarterhorse aircraft. The Quarterhorse is an autonomous aircraft, kind of their demo aircraft. And again, that's meant to be flying in 2023. That's very, very close, right? The star has been underway since 2018. And hypersonics is something that is very, very important. It is the ultimate high ground. It means that you can put a taskable satellite or somewhere in a very, very very, very quickly. You can put some kinetic solution or a sensor or some craft anywhere on the planet in a number of hours. You can observe things better, you can strike things better, or you can get people from one place to the other in very, very fast speeds. So this commercially could be an incredibly vast opportunity for this company. Boom Supersonic is working on a more passenger-oriented vehicle, also using 3D printing, by the way. Also using Velo, by the way, so that's a good thing for the company to be involved in these particular implementations. It's quite early days yet. We need this stuff to be validated. We need these companies to stand up financially. We need orders to come in, and we need them to prove that it's safe and it works. But still, this could have considerable impact on the military way of doing things, have very considerable, very near-term impact. In the long term, will remain to be seen what it means for passenger air travel. If it's, it seems like it's very much going to be a happy few thing for a very, very long time. But these aircraft, saving weight is incredibly important for them because of the materials are so expensive. And reducing part count is incredibly important for making hypersonics, making the craft sturdy enough to withstand its own the pressure it's going to be under, and the pressure of its own movement, let's say it's going to be under, is incredibly important as well. So these aircraft, are going to really unlock a lot of new manufacturing technology. In this case, they're using a Sapphire and they're using Inconel 718 reportedly to make certain components on the aircraft. So very good news for everyone involved, I think. The next thing is that NASA's Marshall Space Flight Center has selected additive monitoring systems to develop in situ monitoring system for 3D printing copper components specifically. So in situ monitoring is something that a lot of the OEMs are working on in various ways. They're trying to understand better what's going on. They're trying to predict or get signal mistakes as early as they can. And the additive and monitoring systems has an optical fault detection system they call Project Fringe. And this will be deployed at Marshall's Center at Huntsville. Specifically, NASA's interested in copper components. These have been used in liquid propulsion technologies, and this is probably where, where NASA's going to apply it, and this GR crop material or others, or pure copper. But also, of course, copper could be really relevant for a lot of electronics and a lot of other components aboard spacecraft. The objective of this is to reduce waste, to increase the yield, to reduce overall cost, get a better bite to fly, and to really understand what's going on and to understand mistakes. Because a lot of powder bed fusion system processes are very black box, and NASA's trying to demystify the process for engineers and for planning and make it a lot easier to, especially to print large components. So think about making an engine, maybe that's a 1 week print. These larger components we're seeing emerge, a 2 week print. Now, if you have a number of machines and you paid, say $1 million for a machine, and it's a 1 week print on that machine, and that build fails, that is a big problem for you for in terms of like the economics of your overall printer purchase, but also meeting scheduling and demands and all these things, and trying to meet a launch window, for example. So this is, I think, a very valuable advancement by NASA that they're trying to, stimulate by the former Argonne National Labs team. The next thing is a research paper by Sebastian Kluck and others from the University of Freiburg. It was released in Nature Communications. It's not only that I'm not trying to only take things from Nature Communications, by the way. This is a replications technique, essentially, or a new way of creating metal objects from molds using glassamer nanocomposites. They can make tooling type inserts and other components in about 36 hours. So that could be, it's much quicker than some other things. They like the surface textures that they can produce as well with these things. I think that could really be usable in a very industrial type way. So the way it works, I hope you can see the image, is that first I use 2PP or two photon polymerization to build the object or the master, right, the positive. Then this is copied into PDMS or cast, sorry, into a PDMS shape. That's then a negative. The fused silica part is then made. I didn't say it wasn't contrived. The fused silica part is then made based on that by casting off of the PDMS replication mold. That's then cured. That material is glassamer, by the way. That's made by like the startup Glassamer. Then this is debound and sintered, and then the silicon replication structure is obtained. This is again is a positive, or step C, by the way, if you're paying attention on the graph. And then the metals are cast against the sintered fused silica replication structure using bronze or another kind of material, and then you get your metal part. Now, this may indeed seem kind of contrived, and hey, we've been doing casting and lost wax casting for like 5,000 years. Why innovate? But it is nice to see somebody do something that may seem quite contrived, may seem like it involves a lot of handling, a lot of process steps, but may indeed be a new way to create certain shapes. Now, these things are, it's nice to see some fundamental innovation going on in stuff that's like ancient, right? And, but we won't know until coming to market what the niche is that can be really comfortably attained by this. Maybe this is a great technology for certain kind of very basic molds, or it's a much faster technology, it's much cheaper for certain shapes or geometries, or for certain sizes of parts. It could be really small parts. It could be a really good alternative to MIM or other processes. So, at the moment, this looks very promising, and it's very exciting to see somebody do something as interesting with something that old and ancient. Thank you so much for being with us today, and I hope you enjoyed the stream and enjoy your day.